When a vertical section is made through soil, it shows a series of layers or zones, each recognizably different from the one above. These zones are called soil horizons, and the successive vertical layers constitute the soil profile. A simple profile has three subdivisions, simply designated as A, B, and C horizons. The A horizon is the topsoil, the part in which we grow plants. It is soft and crumbly and is composed sometimes almost entirely of decayed vegetable matter. The A horizon is sometimes called the zone of leaching or the alluvial or washed out layer. This is because some of its materials move downward by soil water to the B horizon in a process called leaching. The B horizon is designated as the zone of accumulation or alluvial or washed-in layer because of the presence in it of minerals which were carried down from the A horizon. Weathering here has advanced further than the underlying zone, so most minerals of the parent rock are unrecognizable. Other minerals are converted into new minerals or into soluble salts. In moist climates, the B horizon contains an accumulation of clayey materials and iron oxides delivered by water percolating from the surface. In dry climates, aside from clay and iron oxides, deposits of more soluble materials may be found, such as calcite. The C horizon constitutes the lowermost part of the soil profile. It is the zone of partially disintegrated and partially decomposed rock material. This horizon is generally, although not always, the parent rock. There are different types of soil with different characteristics. And in this activity, we are going to demonstrate how sandy soil differs from clayey soil. Edmond?
Okay, for this activity, we're going to use the following materials. 100 cc of sandy soil, 100 cc of clay soil, 2 old mineral water container, 2 beakers containing 100 millimeter of water, rubber band, scissor.
Okay, first could you please show us how to prepare this improvised funnel as well as the receptacle?
Okay, we're going to use an improvised funnel from an old mineral water container. So first, we're going to make a slit, a small slit here, and using a scissor, you insert the scissor so you can cut the mineral plastic container into two. So you have now a funnel and a receptacle.
Okay.
And for the funnel, we're going to use an old stocking.
Yes.
And with the help of a rubber band, we can secure stocking in place. Okay. So we have here the prepared set. So first we have here 100
yeah, that's about 100 cc of
clay soil.
Clay soil.
Another 100 cc of sandy soil.
Okay, there's something we have to remember about the clay soil. If it forms clumps, we have to break the clumps using mortar and pestle so that the clay soil is in more or less
powdery form.
Yes.
Okay, can I ask you, Dr. Carale, to pour this on the sandy soil, and I'll pour this one on the clay soil at the same time?
Yes, we are going to do this at the same time. We are using 100 milliliters of water. Notice that water has started to drip from the sandy soil, but no water has come out yet from the clayey soil.
So you can ask your students to take the time on how long will it take for the water to pass through the sandy soil and
Into the receptacle.
into the
Yes.
receptacle. And also with the clay soil.
After 15 minutes, you can see that water has already passed through the sandy soil. And in the case of the clayey soil, there's very little water that has passed through it. And from this observation, we can infer that maybe much water has passed through the sandy soil because the spaces between the particles of sand are larger, while the spaces between the particles of clay are smaller. To find out if our inference is true or not, we can do another activity. What materials do we need, Edmond?
Okay, for this activity, this time we're going to use the following materials. 3 improvised soil filters, about 100 cc of clay soil, another 100 cc of sandy soil, test tube rock, 8 70 milliliter test tube, and bond papers.
You will notice that the wire mesh at the bottom of the improvised filters are of different sizes. We have here a 2 millimeter wire mesh, a 1 millimeter wire mesh, and 0.5 millimeter wire mesh.
First, we're going to stack up the wire mesh with the courses on top.
Yes.
Then, we're going to pour soil. This time, I'm using first the sandy soil.
You're actually letting the soil particles pass through the soil filter. The soil particles have been categorized into 4. We have the coarse particles, then we have the medium-sized particles, the fine particles, and the very fine particles. Now we are going to transfer these into the test tubes. The medium then now we have the fine. And finally, we have the very fine particles. So we are going to follow the same procedure using the clayey soil. You can now compare the results for the sandy soil and the clayey soil. And if you compare the height of the very fine particles found in the 2 soil samples, you will see that there is much more of the very fine particles in the clayey soil compared to the very fine particles in the sandy soil. And therefore, you can say from this observation that water passed much more easily through the sandy soil because there is less of the very fine particles. Whereas it took a long time for the water to pass through the clayey soil because the soil is made up of very fine particles. There are more of the very fine particles in clay soil compared to sandy soil.